Hello everybody. Engineering Exploration course project title is Bottle Separating Machine, done under the guidance of Raghu sir. The several other teammates include Vinayak, Ninad, Nivedita and Apurva. Problem definition. A recycling plant receives various size bottles every day. The system needs an automated machine that separates these bottles based on their diameter, which later sends them to their particular sections, hence adding to the recycling system. Observations from the survey requirements include that the weight of the machine should be easy to carry and transportable. Number of operations says that the machine should work for at least 8 to 10 attempts. The cost of the machine should be built within minimum budget and the materials to be used must be non-toxic and lightweight. Objectives. The machine should be semi-automatic, it should be user-friendly, accurate, portable, and it should segregate into three categories, that is 2 to 6 cm, 6 to 12, and 12 to 20. Constraints. The machine should not weigh more than 4 kgs. The machine cost should not be more than 4,000 rupees. It should be able to fit in a volume of 3 into 3 into 3 feet. And the machine should be able to sort bottles into three categories, at least sort 3 bottles per minute. The machine should almost sort a bottle of 20 centimeter in diameter. Functions. It should indicate when the process is under action. It should count the number of bottles in each category. It should sort out the bottles and store them in separate boxes. It should sense the bottle. Function tree. The bottle segregating machine function is further subdivided into four main topics. That is handling the bottle, measurement, process indication, casting and storage. Under handling the bottle, it should sense the bottle, hold or release, move the bottle, do not squeeze the bottle. Under measurement, measure the diameter, compare the reading, give correct output or segregate. Process indication, it should indicate whether the machine is on or off, process completion, and indicating the right measured diameter. Casing and storage, casing for the whole machine, store the segregated bottles separately. Function clustering. Firstly, it should sense the bottle, then move the bottle to the appropriate destination where the diameter is measured. Later, the machine should indicate the process of the diameter measurement to be completed, and then it should be further moved towards its particular box, segregating box. The subsystems identified are bottle handling unit, measuring unit, separating unit, and casing. Generated concepts. There were four main concepts which were included in creation of this project. In the first diagram, firstly, we see that we use infrared sensors and mechanical arms, conveyor belt, and a screen to move the bottle, and the bottle is further divided into box 1 and box 2. Second, the second generated concept, the bottle here is vertically displaced to its platform, and then the diameter is measured using the arms, and then further it is put into its particular box. In concept 3, we see that there is a horizontal movement of the bottle along the conveyor belt, and in which the machine is raised to a particular platform. It moves, and the the bottle is moved to the respective block. Then generated concept 4, top view. The bottle is moved over the conveyor belt, and later the bottle is measured using the potentiometer, and then it is moved further using the Doda conveyor belt, and then moved into its particular segregating box. We use the concept 4 for building this instrument.
This is a 3D model of a bottle separating machine, created, designed and modeled in SolidWorks. This model consists of three parts: the conveyor belt unit, the measuring unit, the separating unit. The conveyor belt unit. This unit consists of two conveyor belts, a larger one and a smaller one. The larger one helps in the movement of the bottle through its measuring phase until the separating phase, after which the movement is taken control by the smaller belt. How is it made? The conveyor belt has two parallel sidewalls which are supported and held by a pair of eye structure. The sidewalls are made of fine acrylic sheet and hold two and each conveyor belt hold two nylon rods of 24 mm diameter, all lathed to a specific dimensions. The belt is made of bandage cloth wrapped tightly around the nylon rods. These nylon rods are connected to a 12-volt DC motor through a 1:1 gear ratio controlled by an Arduino Mega, the measuring unit. The primary goal of this project is to measure the diameter of the bottle accurately. This system uses an arm to measure. The arm is movable, synchronized, and calibrated to a potentiometer. The arm is connected to a rack and pinion, which converts the rotary motion of the Arduino controlled stepper motor to linear motion. The changes in the potentiometer is sent to Arduino, which converts this change in voltage to change in distance. From this, the diameter of the bottle can be calculated and measured. The, the separating unit. This unit is for the secondary goal of the project, that is, to segregate and separate the measured bottles according to their category. This unit consists of a flap that rotates at specific direction and at up to specific angle. Let me show you. Okay. This is achieved by connecting the flap to a servo motor controlled by Arduino. From this, the flaps move left or right based on based on the calculations done by the measuring unit. The flaps in okay. The flaps in turn push the bottles left or right, and after pushing, the bottles move left or right, and through the secondary a smaller conveyor belt gets from this it gets separated into respective boxes. This is a circuit diagram of our project. The circuit is powered by a 12-volt battery and processed by Arduino Mega. The circuit consists of a DC motor controlled by Arduino through a dual-channel relay and powered by the battery. The stepper motor is controlled by Arduino through its relay. A servo motor is also used. IR sensors, proximity sensors, and limit switch are connected. A 10 kilo ohm potentiometer is also used to control and direct the stepper motor.
The flowchart or signaling model of the entire system. The flowchart will explain the working of the model. When you start, IR sensors help to sense the bottles and DC motor is on. Stepper motor is on. The potentiometer will measure the diameter. It measures the different types of diameter. The servo motor will help to separate the bottles based on its diameter and process will stop. The bill of material required for the entire system. While preparing the model, we need the different types of materials like acrylic sheet, DC motor, nut and bolts, nylon rod, conveyor belt, stepper motor, relay, rack and pinion, limit switch, potentiometer, servo motor. Then motor sizing and battery sizing of the entire system. We require a torque is 0.22125 Newton meter. The battery sizing we require a battery capacity is 2.71 ampere.
So moving on, we have functions and the specifications. First one is sense the bottle. The specification is the rotation of motor being sensed by the sensor. Second one is indicator. LED indicates as soon as the bottle is sensed. Third one is movement of the belt. Conveyor belt starts rotating until the bottle reaches the exact position. Fourth one is measuring the diameter. The diameter is measured using a calibrated potentiometer. Fifth one is the flap. Changes the direction of the movement of bottle. Sixth one are boxes. Bottles are stored in these boxes.
So moving on to the simulation. The IR sensor detects the bottle. Then the DC motor runs, which in turn runs the conveyor belt. IR sensor near the measurement arm detects the bottle. Then DC motor stops and stepper motor turns on. Stepper motor is connected to the proximity sensor, which helps in detection of distance between the arm and bottle, and is in turn connected to the potentiometer, which finds distance. As soon as the proximity sensor reads zero distance, stepper motor runs in reverse direction. And as soon as the stepper motor comes to the original position, then DC motor starts. While this is happening, servo motor, whose flaps are in left or right direction, depending upon the measurement, pushes the bottle in left or right direction. The second conveyor belt carries the bottle and drops them in separate boxes according